Hi guys, hope I'm audible to you. Yes. So welcome to all of you, and today I'm here to discuss one more machine learning algorithm, which is decision tree, and we'll be applying this machine learning algorithm on the inventory optimization. If you have followed our social media channels, you might have seen the first version of this particular session. The first version was actually when we have discussed the concepts like entropy, information gain, and Gini index. These are the statistical concept or statistics which are going to be used to actually build a decision tree. So if you, I'm not, I will not be able to discuss those concepts in detail once again over in this session. If you want to follow the follow the session which we have done day before yesterday, you you may visit our social media channels on Facebook, Twitter, YouTube, and from where you will be able to access the content of the first content or the first session. So, in case if you're not able to find those links on the Facebook or Twitter or the on the YouTube, you can actually you can ping me on my Facebook page or you can ping me on the WhatsApp, which you can see on the screen, or you can email me. I will share those. I'll share the first session links to you. So there are some people about to join. Let's see if there are some are joined or not. So I think there's nobody joined, but we'll not wait for anybody. We'll proceed ahead to to complete the case study on the right. So I have a data set here, and the data set is we have a stockout on the data. And so here I will define the data first. So first of all, let's say our dependent variable or what we are predicting. Our prediction is that whether we're going to have a stock out or will not have a stock out, right? So if it is stock out, we'll define it as one, and if it is not a stock out, we'll define it as zero, right? So these are dependent variables. So we have to make a prediction. We have to make a prediction whether a particular SQ, right? A particular SQ will have a stock out or will not have a stock out. So we have to make a prediction in advance. So we are going to make this prediction based upon certain causes, or let's say they are called independent variables, right? The prediction of the forecast we're going to make based upon the independent variables. So independent variable which I'm choosing over here, in this case, in this data set is first one is lead time. Second is forecast accuracy. Third is factory capacity of supplier. Right, this is also from lead time from supplier. So we are trying to we're trying to focus on our upstream, right? We're trying to focus on the upstream, and from the upstream we are trying to understand our stock out rate, right? So this is how we can actually optimize our inventory. So we are trying to focus on the upstream side. So these all variables belongs to the upstream variables. So if you know what is upstream, so upstream is suppose we are a factory, we belong to a factory, right? This is our entity. So there are two chains before factory and after factory. After factory, we have a customer, and before factory, we have a supplier, right? So this when so supplier does the shipment to our factory. So this area is called or this area of stakeholders, we call this as a upstream. And the point or the place or the stakeholder where we are the supplier and we are going to deliver the product. So this area is called downstream, right? So towards our customers, towards the customer side from the factory, that's called downstream, and toward the supplier side from the factory, that's called upstream. So what we're trying to do over here is that we're trying to connect. So we are trying to connect our upstream with the stock out rate of the products. So what is the impact of what is the impact of upstream over the stock out rate of products at the factory, right? This is what we need to understand. If we understand this, so at least we can control the stock out of the products from the upstream side, from the supplier side, right? So we want to minimize the stock out rate from the impact or the costs, causal factors from the supplier side, from the upstream side. This is what we want to do. And this is we're going to achieve, this is what we're going to achieve using a machine learning algorithm. We'll achieve this using machine learning algorithm called decision trees. There are various ways, the various machine learning algorithms are available, but today our focus will be decision trees. So decision trees is something like if you might have heard, so suppose this is my node, right? This is called root node. So there is a way to build a decision tree based upon a statistical parameter. So there's a root node, whether we have a stock out or not a stock out. Right? I'm just building a general tree, but this is not the way we're going to build. Just if a stock out is there, what is the reason for stock out? Is it because of high lead time or is it because of low lead time? So there's one more node here, right? So there's one more node. We are going to make a decision here. Is it because of high forecast accuracy or a low forecast accuracy? If it is lead time, again we have a node here. If it is a high lead time, is it because of the high factory capacity or a low factory capacity? If it is low lead time, is it because of high factory capacity or a low factory capacity? If it is a high forecast accuracy, is it because of the high factory capacity or is it because of a low factory capacity? If it is a low forecast accuracy, is it because of high factory capacity? Is it because of low factory capacity? Right. So we're building a decision tree. I'm not this decision tree I'm building. randomly without using any statistical parameter. But when we are going to build a decision tree, it has to be based upon certain algorithm, certain statistical parameter. So this is how we are going to make decisions, right? So this is a decision tree without using a statistical parameter. So decision tree is used very much in the in pharmaceutical industries, in e-commerce industries, in space research, in in making logistical decisions in various 3PL, 4PL, 2PL, as well as the defense sector. Right? So there are a lot of applications are there of of decision trees. Especially in the risk. Suppose if you want to you want to calculate your risk, if you want to understand, you want to assess your risk, you want to mitigate your risk, you want to have the high recovery rate from the risk. Right? So decision trees are used very heavily over there. Right? So decision trees are used very much in logistics management or logistic decision making logistic decisions. And this is why it has a very high applicability in the space research, in the medicines, in the defense sector. The very very high application. And one of the in supply chain, on the logistical decision making, the risk management is the area where it is heavily used. And post COVID, right? Every factory or every business wants to invest their resources, their on risk management, because the COVID has, you know, COVID has brought them into a situation where they were not able to execute a proper decision. Means it has completely paralyzed them. So now most of the businesses are actually trying to invest into supply chain risk management. And algorithms like decision trees are very helpful with business or to the the businesses or non-business sectors, right? Or profit making sector, non-profit making sectors. So or whatever whatever they are. So they're applying some these decision trees very much into risk management. So if you want if and coming days supply chain will not be called supply chain. Supply chain will be called supply chain risk management, right? Because if you're managing a risk, your supply chain is managed. That is the way the industry is looking now. So if you manage your risk, you're managing your supply chain. So the supply chain is not a supply chain. Supply chain is a supply chain risk management. That is how the industry is looking for. So if you want to become a very good professional, if you want to become very useful professional for the industry or for your team or a group, whatever you are, so you must learn decision trees as one of the tool to perform decision making or forecasting or prediction or management making taking management decisions in terms of from the strategy point of view or tactic points of view, from the execution point of view, from whatever point of view this can help. So this is how the problem statement. So we are using dependent variable means or target. What is the target? Whether we are going to have a stock out, we are not going to have a stock out. We want to find those scenarios, right? So what are those scenarios? The scenarios are based upon these three independent variables. So we have taken lead time from supplier, forecast accuracy between supplier and the factory, and the factory capacity of supplier between. Hi, hello, I'm audible to you. Hello, if somebody was calling my name. So if you have any questions, please feel free to ask. Right. So lead time from supplier, forecast accuracy between factory and supplier, and the factory capacity of supplier. We're using these three variables, but in the real time, we may use hundreds of variables, right? Hundreds of variables we can use, and from those hundreds of variables, we can come up with a decision. So this is what the problem statement. This is what our variables which are we're going to use to make the decision. And we already know that entropy, information gain. So this is what I discussed in my previous session, and Gini index. Right? These are three metrics we're going to use to understand our to build our decision tree. Okay. So what is entropy? Entropy is, we know, the degree of randomness or degree of information available or clear information available. If the information is not very clear, so we cannot make a decision. If the information is very clear, we can make a decision, right? So how confused is the information? How noisy is the information? If the information is noisy, information which we have for making a decision, or information which we have for making a decision means we have to make a decision. We have to make a split. We have to split our variable. Means if the split is clear or split is not clear. Suppose we are making a decision tree, so that we have to make a node and we have to split it. This node into two parts or three parts, right? So we have to split the node into two or three parts. So this, if this information is very clear, then we can split. So if the information is very clear, then we say the entropy is less. If the information clarity is higher, then the entropy is lower or else higher. So higher the entropy, poorer is a decision we will make, right? So if I do not have the clear information, I'll make a poor decision. If I do not have clear information, right, the decision will be poor. So what we want to make good decisions. Our objective is to make good decisions, right? So if you want to make a good decisions, so what we have to choose? We have to choose variables with lesser entropy, because entropy is a measure of poor information or confused information or noisy information. So we have to choose variables first, which gives us the best entropy, or sorry, lesser entropy. So this is how. So this is, if you want to understand which one is the least having the least information or better information, right? So if you want to measure which one has the better information, we will use the metric called information gain. Okay, so this is a metric, information gain, which is derived by using the calculations of entropy. So we will be understanding which particular variable is giving us the best information with lesser noisy information. So that is the variable which you're going to pick. Similarly, Gini index is another metric to compute the entropy. Right? Gini index, if you want to use, we can use two different statistics. Either we have to use entropy and information gain to make our decision tree, or you have to use Gini index. Either one of them we can use to make our decisions, that which variable gives us the best split or best understanding whether we have a stock out or we will not have a stock out. So these are the intuitive definition of entropy, information gain, and Gini index. So all are the measure of randomness or the noisy information, right? So we need to have a clear decision. We want to have a clear decision, so we need to have a clear information. We want to get rid of the noisy information. Okay, so let's measure this. Let's work on this algorithm and clear make our decision tree. So I have a data over here, and I'll be working on first uh, Gini index. Then afterwards we'll go into the. Let's work first on the information gain and entropy. Then we'll see the Gini index. Right, that's the better. So now if you look at here, my dependent variable already I mentioned that is stock out. So there, wherever we have a stock out, we'll mention as 0. Wherever we mention 1, and wherever we do not have a stock out, we'll mention as 0. Right. So in this data, particular data, let me give the insight. So I'll go and put the filter here. So wherever if you see 0, 0 means we have no stock out, and wherever we have 1, it means we have a stock out. So that's what I mentioned over here. Stock out is equal to 1. If it is not a stock out, then it's 0. Right. That's how we are defining our. And this is a categorical variable. Right? This is a categorical variable. Means we don't have any numbers over here. Either if you look at there is a number 0 and 1, but that 0 is 1 is not a number. There's a category. Stock out is 1 and non-stock out is 0. So this is a categorical variable. So we are making a decision here. We are making a classification here. So that's why decision tree is called a classification algorithm. So we are making a classification. If you have to make a decision whether I will have a stock out or I will not have a stock out. So that is a category. So this is a classification. So this is we are making a decision based upon a classification. We are not trying to measure any accuracy parameter like 20% or 30% or 40%. We're not trying to measure the profit margin. It is 70% or 80%, 15%. We are not trying to measure the forecast accuracy whether 30%, 70%. We're simply trying to measure what is our whether we will have a stock out or we will not have a stock out. Right? That is the classification. Now, if you look at the lead time, so lead time we have here the various numbers. This is not a class. This is not a categorical. Lead time is not a categorical number. Lead time is like what is the distance? How many days we will take to do the shipment from the point when we give the order to supplier to the point we receive the product from the supplier. Right? So the time gap. Suppose I give a time gap. The time gap is, let's say, I'm mentioning that on 1st of July, I gave the order, right? 1st of July, I gave the order to supplier. Okay. On 10th of July, I received the product. Okay. What is the gap? The gap is 1 minus 1st July, 10 July minus 1st July plus 1 because we have to add the 1st July also. So we have taken, so since we have gave the order on 1st July, the 1st July will also be considered as a operational date, right? Some of the industries say that the day of order they will not consider as an operational date. Some of the industries consider the day of order as also as the operational date. If you consider the day of giving the order as an operational date, you have to add plus one. If you consider that the day of giving the order is not the operational date, right? Then you have to remove zero, this one. So in this case, we're considering, let's say if you do not, if you consider what happens if you consider the 1st July also as also as an operational date, right? In that case, it will be 10 days. And if you consider the 1st of July is not the operational date, in that case, it will be 9 days. Okay, so it is your choice and because every company has an agreement with the suppliers. So based upon the agreements, they will actually follow up there. They have to do the measurements. So let's say we are taking plus one. So here we are saying 10 days. So the gap between the supplier order date and the product receipt date is called lead time. So this is not a category. This is a number. Okay, not a category like we have the dependent variable. It is our stock out rate. So here we say the lead time is a. So what I will do, I'll convert this lead time into category. I'll write LT underscore category. And this is I'm doing because I could make the entropy calculations based upon category. So what I'm going to do is that if my lead time is less than equal to 3, let's say, I'll say it is 1, or I'll say it is a 0. If it is less than 1, it's 1, let's say it's better to put 0 or 1. So if you look at here, the lead time is less than equal to 3. That's why it is 0. Okay. So this is what I have converted this lead time into a categorical variable. Similarly, if you look at a forecast accuracy, right? I'm going to convert this forecast accuracy. What is forecast accuracy? The forecast accuracy in this case is not, there are two kind of forecast accuracies. One, you do measurements. You have a sales data and you have a forecast data. And what you do, you measure forecast minus sales, that's error, right? And then what you do, you divide the error by sales, right? This is one of the forecast accuracy. Okay, but in our case, this is not the way we are going to measure. So what happens here is that we are going to take the data from supplier stocking, supplier stocks. Some supplier stock is 20 units, right? And we forecasted that we will require 35 units from supplier, right? So here we are going to put our forecast versus supplier stock. What was supplier stock in the warehouse? Okay. So here going to we measure 35 minus 20 divided by supplier stock. This is another forecast accuracy. So we have this is called we can also define this as not forecast alignment. Instead of forecast accuracy, we can also say this is a forecast alignment between supplier and factory. The supplier and buyer. So this is what we are doing. So this is a very important metric, forecast alignment. If you have the right forecast alignment between supplier and factory, so the chances of having getting a shortage from supplier can be minimized. Which is ultimately we want the inventory optimization, right? If you want to have inventory optimization, the forecast alignment is a strategy. We can use forecast alignment as a strategy or a tactic to bring that alignment. If you bring that alignment, of course, you will see the minimization of the stockouts. So this is how we are going to understand our forecast accuracy. So for forecast accuracy is not between the sales and the forecast. The forecast accuracy is between the supplier stock and versus the factory stock. So again, I'll convert this into a category. So forecast accuracy category. So here I'm going to use a formula equal to if if this is less than, let's say, 50%, right? I'll put 0 or else 1. So less than 0, less than 50% is very low accuracy. And if it is more than 50% is a high accuracy. So what is 1? High accuracy. What is 0? Low accuracy. Similarly, I'll go to factory capacity. I'll create the same category over here. Forecast, sorry, factory capacity category. And I'm going to use a formula here. So if the factory capacity is more than 50 or less than 50, let's say, less than 50, less than equal to 50, then it is 0 or else 1. So I'm using a conditional statement here. So this is a conditional statement which we use in Excel. So now we have the category. And last one is contract existence, right? So what happens is if you have a if you have a contract to supplier, what is contract? Contract is a long, yes, contracts create a security of supply between seller and buyer, right? Create security of supply. It means we get on time and in full. So that's this is called OT, on time in full. So this is one thing. We can also go discounts. If you have a contract with supplier, we can also get discounts, right? If you have a contract with supplier, right, we can work with them in processes, right? So there are various advantages are there. Suppose process is to improve the quality. So of the focus is to have the quality, right? So in short time is called OTC on. So this is on time delivery. Then we are then we have a discount means cost OC and then quality. So we can actually manage this OCQ, right? Delivery, cost, and quality if you have a good contracts. And this will help us to minimize our stockouts. So whether we have a contract or we do not have a contract. So we want to see the impact of contract is there on the stockout or not. Or is a it doesn't matter whether it's a whether you have a contract or doesn't have a contract, the performance is same, right? So that is also what we have to look at into. So this is all about our data set. And why did we create this data set? Also, I have mentioned over here, right? Now we are going to use the data set to create our entropy and information gain. And we know what is entropy and what is information gain, right? So how clear is the information we have? How unclear is the information we have? If the information is very have a lot of confusions and unclear, there's a lot of noise, or it's not unclear, then we say the entropy is very high, right? And if the entropy reduces with the introduction of certain data variables restructuring, that is the information gain. So whatever the initial entropy was there, are we able to reduce that? Are we able to reduce that entropy, right, with the introduction of a variable, right? If the we are able to reduce the noise, or if we are able to increase the clarity, it means the information gain is higher. So that is what we are going to see. So which variable is giving us the highest information gain? So first of all, what we do, we calculate the entropy for each of this variable. So first is our stockout frequency. Okay. So what I will do to do the quick analysis, I'll go to insert and I'll use pivot table. Okay. So pivot table can be seen into not two different ways, like what we see here. So what I'm going to do, I'm going to make this a classic pivot table, because the classic pivot table gives a clear structure of rows, uh, columns, and values, right? So guys, if you have any questions in between, I would like to ask. If you have any question, please ask the question, because now we are moving into the final stage of our computations. So if you have any questions, you are free to ask. Yeah, Mr. Amit, Mr. Ram, if you have any questions, you're free to ask. Till now, up till this time, what you have covered. So I know you're attending for the first time. You maybe might be actually hearing about this algorithm for the first time. You might be hearing about supply chain for the first time, probably. You might be hearing about this algorithm or this metrics for the first time. I know this could be little clumsy. I completely accept that, because if that is happening over here. But when we deliver the training program, it will be very structured training program. So you will be given the training very structured. So right now we are directly going into algorithm. But in the training program, when we do conduct the training program, we'll not directly go into the algorithms. Right? We'll be giving you a structured training, and that structured training will make you will give you a lot of comfort to understand these kind of complicated algorithms. And this is supply chain analytics. So we use data-driven approach. We do use algorithm approach. We use machine learning approach to make supply chain decisions. So this is what different from supply chain. If you are from supply chain, you might be making decisions based upon certain plans, certain reports. But this is making upon the predictive analysis. Means you are going to make your decisions a lot earlier than you're making now. So once you know what is going to happen in future, suppose some bad event is going to happen, some bad outcome is going to occur. So once you know those in advance, you will be prepared in advance to tackle that. So that is the benefit. Generally, what happens, supply chain, a lot of analysis is done after the events are occurred, after the outcomes are occurred, right? So that those things can only help us because we already have seen the outcomes. We cannot do anything on the already occurred outcomes. But the benefit with this kind of is you are going to know what is going to happen in future, and you're going to make your tactics or strategies in advance so that the negative outcomes should not occur. That is the difference between the supply chain, normal supply chain, and a predictive and a proactive supply chain. So let us make the our data set. So what I'm going to do is I'm going to take my stock out frequency. I'm going to put that into over here, and I'm going to also put this into values, right? So this I'm going to convert into count. So now if you look at this particular data set, so what we see over here is the count of zero. The count of zero is means our stock out is 18, and the count of one, which is 27, is means the no stock out 27, right? So if I mention over here stock out is equal to 18 and no stock out is equal to 27, right? Total. So what is the probability of stock out then? Probability of stock out is 18 by 27, 18 by 45. What is the probability of no, so this for to understand these formulas and everything, you have to go to our first session, which we have conducted on Monday. So I have explained there. If you want to have the link, I will share the link also. So what is the probability of no stock out? It is 27 by 45, right? So uh, so this is what we have, and the computations for entropy is minus 18 by 45 into log to the base 2 18 by 45 minus 27 by 45 into log to the base 2 27 by 45. I have explained how this formula is derived also in the session, right? So in the first session, if you visit the first session, you will also get how this formula is derived. That also I have also defined there. So this is the formula of entropy. Now, if I use this formula of entropy of the outcome, so this is minus 18 divided by 45 into log to the base 2. So I'll take the formula of log. The number is 18 by 45. That's what for year one. And the base is 2, right? Same thing I'll do for here. Minus 27 by 45 into log of 27 by 45 to the base 2. So currently what we see, the entropy is equal to 0.975 of the dependent variable. So the entropy of the stockout category is equal to 0.97095. So we can say 0.97 or 0.971. Okay, this is the entropy of the. So now what we have to measure is the information gain, right? So for measure the information gain, again we go back to the pivot table, and this time I'm going to put the first category, lead time category. I'll put the stockout category in the column. I'll put the lead time category over here. So it's not lead time category. Okay. So what we are going to do, first we're going to measure the entropy for the lead time category wise. Entropy of the lead time category wise. So the entropy of the lead time category wise. So what we're going to do, So now we are going to measure the entropy of the category lead time. So let's say I'm going to measure, let me put the numbers here itself. Entropy of the lead time. This is a very complicated algorithm which I have already explained in the last session. So entropy of the lead time category wise. So what I'm going to do, I'm going to put the formulas. If I'm going to go to pivot table valuable settings, I go to show value as, I'll go to percentage of column total and put this. So I'm directly getting a values over here. So what I'm going to do, I'm going to take these values. So I'm going to put 0.27, 0.2778 into log to the base, log to the base 0.2778 comma 2, right? And I have to put the minus sign here. So this is again minus sign I have to put here. So minus sign, and I'm going to put 40.74, 0.474 into log of 0.4074 to the base 2. So this is 1.04, right? This is for the zero category, lead time, zero category. Entropy. So this is my entropy. I'll give a column name, entropy, and this is my category. Okay. So now I'm going to measure the lead time for one category. Entropy for lead time, one category. So what I'm going to do again, I'm going to take this value 0.722 minus 0.722 into log of 0.722, 0.722 to the base 2 minus 0.59, 0.5926 into log of 0.5926 to the base 2. So what we got here is 0.78, right? Now what I'm going to do, I'm going to find the overall entropy of the lead time, right? For that, what I'm going to do, I'm going to take the weighted average. So this is my 0.3556, which is coming from here, into 1.04 plus 64.44%. Sorry, I have to put the numbers. So 0.6446 into 0.78. Right. So this is my overall entropy, and I have to measure the information gain now. The information gain is how much was the initial entropy, how much was the initial entropy minus how much is the entropy coming from the lead time, right? That is 0.09. So how much entropy has been reduced, right? How much information gain? So how much entropy has been reduced? So information gain is how much entropy we could able to reduce. That's a 0.093 coming from lead time. So similarly, now we are going to do the same process for the next category, next variable. So I'll remove the lead time category from here. I'm going to take forecast accuracy category from here. So I'll put the forecast category here. So now by putting this forecast category versus stock out, right? Now we're going to do same operations for forecast category, right? So now let's say forecast category. So we're going to pick which variable gives the best information gain for our splitting variable to make a decision tree, the first decision tree. So forecast category, again, I'm going to use forecast category, that is 0. Similarly, we'll go forecast category 1. right? And I'll measure the overall entropy of forecast category, and then we'll measure the information gain from forecast category, right? So let's measure this one by one. So this is our entropy. So first we'll go to let measure here. So this is equal to 44.4% into log of 44.4%, comma 2. So I have to put a negative sign also here. Right? I'll put minus again. I'll take this value into log of this value, comma 2. I'll enter. So this goes, I have got 1.04. I'm going to copy this, paste special values to remove the formula. The formula has been removed. Same thing I will do with the next one. So next one, what I'm going to do, I'm going to take 55.56. Uh, I have to put a negative sign first. So this is negative sign into log of this number, comma 2, minus, I'll take this number into log of, I'm just taking this process faster. Now I got this. I'll remove the formula from here, copy and paste special values. So now we're going to measure the overall entropy. So measure the overall entropy. What we'll do? We'll multiply this number with our first number, and we'll multiply the second number from here to the second entropy, which we come from over here. So now this gives us the overall entropy from the forecast category. Now what we're going to do? We're going to measure our information gain. So what is information gain? So here we are getting this value minus this value, right? So we got a negative value over here, right? Now similarly, we'll do the third operation. The third operation is for, let's look at the data. So the third operation we'll do for the factory capacity. So I'm going to put the factory capacity over here, right? So now we're getting to find, we have to find our information gain for the factory capacity. The same thing I'll do again. So factory, I'll just copy this, paste over here instead of 4. I'll mention, I'm doing everything fast. The first thing I did, I gave a proper visibility, but from that point, I'm going a little faster, right? So now this is, when you join our training programs, you will learn all those things from us, how to do things faster and all those things. So now we're going to do entropy. So entropy for the forecast capacity, let first of all, I have to put a negative sign again. So negative sign into this into log of 27.7% 2, comma 2. Again, we have to put a negative sign. Take 51.58% into log of this 51%, 12.8% to the base 2. So this is our entropy for the factory category 0. Now we are going to measure the entropy for the factory category 1. So I already put this time negative in the beginning itself. So now this is our comma 2 minus, so this 48.15% into log of this number, comma 2. So this is what we got, 8.5%. Overall, we're going to measure, now we're going to measure the overall this into this, right? This into this plus this into this. So this is what about your, the overall. Now we're going to measure information gain. The information gain, we have to measure our initial entropy for the dependent variable, and so I'll what I'll do, in order to think faster, I'll take this and drag and put over here, and I'll copy this and paste special over here. So now why I did is because now we get automatic calculations. So automatic calculation means simply I'll go here and change my category. So I'll remove from this and go to contract category. Right, I'll put contract category. I'll get the automatic values. So we didn't get here. So we have to see where the problem. I thought we'll get the automatic values over here. So we didn't get getting some error. Yeah. So now I'll go ahead here and replace the fact with contract. So where is the difference? So I'll go and change from here. First thing, the fact to the contract. Couldn't find anything to. Okay. Okay. So this has to be fact now. This is FACT. So if you want to change the fact to close, then you go replace all. So now all the facts have been reduced to con. Now this formula, there is some error we are noticing here. So let's see where is the error. So I thought it will work by itself, but it is not working by itself. Okay. So let me remove this formula. Okay. So I'll put the formula again. So minus. So here we got 55.6% into log of this 55.5% into 2, and now put a minus. So this 51.5% into log of 51.5% to the power 2. So to the base 2. We get 0.96, right? So now I'll go to second formula. Minus of 44.44% into log of this 44.41%, comma 2, minus of this 48.15% into the log of this 48.5%, comma 2. We're getting 1.02. Now we're going to measure the overall. Overall, what we do, we do the weighted average. So we'll multiply 53.3%, the first value, plus 46.67% into the second value, right? So this we got 0.99, and this is taking the formula. This is difficult for the first time because you're listening for the first time. So this could be quite cumbersome or clumsy. So don't worry, because if you join our training programs, you will learn everything from the basic. So if you have any question, I know this will be difficult to grab in the very first chance. So if you have any questions, please you can ask. We can have a discussion. So we have now our four variables: lead time. I'll just color them. We have the forecast accuracy, a different color. Let me put a light color. I'll put a forecast accuracy. Okay. Now third is forecast category. This is our factory capacity. And the last one is contract existence. So we have these four variables, and for this from these four variables, we have to choose which one has the highest information gain. Right? Which one has the highest information gain? So if you look at the information gain, this is point. So we are going to take max of all of them. So comma, this is comma, this is also a comma, and this also a comma. Right? So max is not working. Okay, I had to put X here. So 0.093. The 0.9093 is coming from the first variable, which is lead time. So lead time was giving us the most highest clarity. The information gain The information gain is coming highest from the lead time. So we are going to use lead time as our first variable to make our tree, right? So how to make this tree? So now let's say I have a root node here. So this is a root node. Okay. So this root node will be lead time. Okay. So we have two categories over here. And these are branches. This is our node, root. So we have a tree, right? Tree comes, suppose we have a tree like this, right? There is a one, so there is a branch coming from here. So this branch is coming from the main tree, trunk. So this is a node. So this is called root node. From this two root node, we have branch one and branch two. Okay. So what is branch one? Zero. What is branch two? One. Right. So if I go to the branch, I'll remove this contract existence because the best information gain we come getting from lead time category. So if you look at the lead time category from branch zero, right, we have how much? We have our stock out percentage how much? 27.78%. 27.78%. And from not a stock out, it is 40.74%. Similarly, from branch one, we have again a stock out and no stock outs. The stock out is how much for branch one? 72.2%. Sorry, yeah, 72.2%. And we have to convert this in percentage, right? So first of all, what I'll do is I'll go back to valuable settings and go back to your value as, and here I'm going to put this as no calculation. So I'll get a numbers over here, right? So now let's, instead of percentage, let's put the numbers. So this is 5 and 11. 5 and 11, and this is 13 and 16, right? So if you look at this, still, when you, is it, if suppose if we have a root node from lead time, the lead time is, if you look at the data, what is the lead time? What is lead time? Zero means if it is less than 3. Zero means if it is less than 3. If it is less than 3, if it is less than equal to 3, and this is more than 3. If the lead time is less than equal to 3, are we getting any clear indication or clear decision, right? Clear decision, are we going to have any stockouts? Complete stockout, right? Or complete, not a stockout. If you look at here, 13 and 16, right? We don't have a very clear understanding. If the lead time is less than 3, we will have a clear stockout or clear not a stockout. Is something looking like something, very, if you look at here, 5 and 11, right? So 5 and 11 is something like, if you look at here, if you look at here, there is 31.25%. 31.25% is 31%, and this is 69%. And if you look at here, this is 44 and 55%. So we are not getting a very clear understanding whether lead time is a factor which will tell us clearly whether we have a stock out of an item or not a stock, not going to have a stock out of an item. So if this could have been, of course we have some clarity over here, but this is very confusing. 44%, 55% are very closer to each other. But here we have certain clarity. So 31% and 69%. Certain clarity we are able to notice in this point. But at this point, we're not having a clear clarity. So we have to further build the tree using the same approach. We have to further build the tree. So now within whenever we have a lead, now we have going to reduce our data structure. So if suppose we want to build next tree, if you want to build a next tree, what I'm going to do is I'm going to build, I'm going to bring another variable here. So lead time, within lead time, how much? So we have to take this pivot table, certain different sheet because we have clouded there, right? So what I'm going to do now, within this lead time category, how much is the forecast accuracy category? Forecast accuracy category. Now we are going to build our entropy based upon within zero of lead time category, how much are the forecast one? Within the lead time category one, how much is the entropy within the forecast category? Similarly, I'm going to build my entropy, next entropy for factory capacity category. But that also will be within the lead time category because we already have a built our first node. The first node is lead time, and this is 0 and this is 1. Right. Now our second node which we'll build within 0 and within 1, right? For this is we have to choose which within 0 among the variables forecast accuracy, factory capacity, and contract existence, right? Within these three variables, within the 0, which one gives the highest information gain? Now, within 1, lead time 1, among the variables forecast accuracy and factory capacity and contract existence, which one gives the highest information gain? For example, if I, for example, just we have to calculate statistically 0 and 1. For example, contract existence give me the highest information gain here. So again, I'll build my tree. And this node is now contract existence. Within 1, suppose I get the highest information gain from the forecast factory capacity. Factory capacity. So again, I'll build my tree over here. Right? Now we are building this tree at branch level, not at the and every branch level, and every branch, every category in the branch is becoming our node. Again, we are going to now build a next tree based upon two care. So suppose lead time 1 and factory capacity is 0, right? This is a tree. This is a branch. Under this, we are going to build again our next tree based upon the information gain. So lead time is equal to 1, factory capacity is equal to 1. So this is the branch. Under this, we're going to build our next tree. Similarly, here, lead time is equal to 0 and contract existence is equal to 0. Under this, we're going to build our next tree based upon the which variable gives the highest information gain. So next here is lead time is equal to 0 and contract exists equal to 1. So this is 1. 0, sorry. Yeah, this is 0, right? So now we're going to, or let's say this is our, yeah, contract existing 1. So 1. So under this, we're going to build our next branch. So like this, the tree is going to build, and at the final level, final level, we're going to build our algorithm, or we're going to make our criteria. So if lead time was 0, lead time was 1. So again, the contract existence was 0, contract existence was 1. The forecast, the factory capacity was 0, factory capacity is 1, right? So now we're going to build our next tree, which is our uh, forecast accuracy is 0, forecast accuracy is 1. Forecast, now here, let's say forecast accuracy is 0, forecast accuracy is 1. Now, what we are going to do is we are going, suppose we arrive the maximum clarity here. This is a path. right? At this path, we get 10% no stock out and 90% stock out, right? So this is what we're getting the clearest, the maximum information. So what we say, if lead time equal to zero, and if contract's existence is equal to zero, right? If forecast accuracy is equal to one, right? We get the chances of stock out is the highest. So it's a very clear decision we're getting now. If lead time is equal to zero, contract existence equal to zero, forecast equal to one. What is lead time equal to zero? Lead time equal to zero means if the lead time is less than 3 days. If the lead time is less than 3 days, contract existence equal to zero. It means there is there is a contract, right? And the forecast accuracy is one. It means the forecast accuracy is more than equal to 50%. Then what we are saying is that, of course, this is irrational, but the stock out chances are 90%. This is what a clear path we are getting of making a decision. So decision trees are built using entropy and information gain. So whichever gives the max information gain, that will be used to build the branches. So to build the entire structure is very time consuming. So I'm telling I gave the initial explanation that how entropy and information gains are used. So based upon which particular variable gives us the information gain, they're going to use that variable to bring that to build the tree. So here, if you look at zero point 0.09 we got, and this 0.09 is actually giving us, we are going to use for the tree building. So this is our root node, and you have two categories, 0 and 1. Now we are going to further build our next root node and next branches. So next branches we are going to build again by building our next pivot table. And the next pivot table, what you look at here is now within zero, right? Within zero, which particular variable gives the highest information gain? Within within one of lead time, which particular variable gives the highest information gain? So like this, we are going to build our the decision tree, till we actually get the very clear information, right? We have to stop at some point. We have to stop at some point. So we are going to stop at some point, which gives us a very clear information, like we are stopping over here, 10% and 90%. This is very clear information. 90% chances that the stock out is there, 10% chances the stock out is not there. And what is the root? What is the branch flow? This is a branch, right? What is a branch? Zero means less than equal to 3 days. What is the meaning? What is the meaning of branch over here? Contract existence means the contract exists. What is the meaning of F equal to 1? Is more than equal to 50%. So if the lead time is less than 3 days and there is a contract and the forecast accuracy or alignment is more than 50%, this is the outcome we can to notice. So if you know this thing, I can actually work on the SQ and take immediate steps to control the particular negative outcome. We want positive outcome. We don't want negative outcome, right? So I can control the positive. I can change the negative outcome to positive outcome by taking a good decision, by taking good strategies and tactics. Right? That is how we are going to build our decision trees, and this is how it helps in supply chain risk management. In supply chain risk management, there are various kind of algorithms which can be used. Right now, we have used entropy. We've taken the support of entropy and information gain. Like this, we can take support of Bayesian statistics. There are various kind of algorithms are there. So Bayesian statistics, right? So we can take support of various kind of statistics, and finally, we can actually arrive at a proper decision with highest information gain, means highest clarity. We don't want lowest clarity when we make a decision. We want highest clarity to make the decision. If you want to make higher, you want to make a decision with the highest clarity, then we need to use information gain as the metric. So this ends our demo on making a informed decision on inventory by taking the support of pivot table using the metrics of entropy and information gain. So if you have any questions, you can ask. And I want to just update that we're launching our training program, which is very structured training program, very step by step training program. of training everything on supply chain as well as mathematics as well as on data on and tools also from 4th August. And we are, the training will be the timings will be 7:30 p.m. to 9:30 p.m. and weekly there will be three sessions on Monday, Wednesday, and Friday. So there will be three sessions Monday, Wednesday, Friday, 7:30 p.m. to 9:30 p.m. And if you want to contact me, you can contact me at krishnaidu@mathanal.tech. You can also contact me at mathanal.com also, mathanal.com. You can also contact me here. And our website is www.mathanal.tech. You can visit our website over here and to get more information. You can also WhatsApp me at +91 89777924637. You can contact me over here. Registrations are open. And once the registration is over, we give you a cloud access to our portal, and you will be, and also will give a calendar invite. You can join the meetings on as per the given time and given schedule. Okay, so any questions, Mr. Amit, Mr. Hari? I'm fine, Amit. How are you? Yeah, Amit. Yes. How are you? Yes. 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 If I will show you the portal here, this is a portal, and we create this kind of portals here. And now this is it is recent batch file. So files. You will also get the same thing, and there is recording. There is a recording folder. So these are the recordings of the sessions which we have conducted till now. Like if you want to go, if I go to another team, another training batch, I'll go to here again recordings. So here are the recording session which we have, right? So you can suppose you want to see recording if any of the session, click on that recording and you will get the recordings like this. So you can watch recordings. Like you have to put permission off. Right. So in case if you have missed the session or if you want to revisit the session after the session, so this is a portal which the access will give you live session recordings, which you the access you will get. And from this as from here you can revisit the recordings in case if you want to, and you can revisit the recording as many times you want, or in case if you have missed the session also you can access the recording from here. We'll also give the access to the total files. Well, these are the files which we, these are the templates which we cover during the training program. So all these templates also you will get in the, you can download the templates from here, like download option is there. You can download these templates and put inside in your local folder. So this is another advantage. So all these templates you can directly use on your projects. These are all like products. These all templates are like a products. We can directly deploy on your own projects on your own data. This is another advantage. We also provide like books, right? Somebody wants to go through the books and read them, right? So these are all the e-books which we have. So they're very costly books, but we are providing free of cost. So n number of books are there. These are all PDF versions. So you can also download these books and put into local folder and you can read these books. So there are three things we provide. And this is a portal. So we will once the person registers, we'll create the and there is a meeting invites you'll get on your local on your email. So all these meetings are there, the sessions are there. So all these sessions will be, we'll also get a meeting invite. This is how the process works. Yes, Amit. Yeah, this is for 1 year. Yeah, this is for 1 year. 1 year. After 1 year, if you want to get the re-access, then you have to pay certain a nominal amount, and then you get the access for next 1 year. So one for the first 1 year, it is completely free. You can and as far as the books are concerned, and as far the Excel files are concerned, you can download and put into your local folder. There is no restrictions on that. But as far the video recordings are concerned, there is a restriction for download. So the video recordings are not allowed for download. And Excel files or templates and books are allowed for download. Yes, yes. You can access your Excel files as well as books anytime. You can download them and save into your folder. But video recordings are not available for downloads. And 1 year access is free. 1 year access is free for the videos. 1 year, full 1 year is access is free. Yes, this is 70 hours program, minimum 70 hours. So it will take, suppose we start in August, it will complete by the end of October. Yeah, if somebody wants the certificate of excellence, there we provide two certificates. One is certificate of excellence, and other is certification of participation. If somebody wants certification of participation is given to everybody without any exam, but certification of excellence is provided after the exam. So we'll conduct two exams, one in between the session, and one exam after the session. So two exams will be there. So we are going to split the total content into two parts, so that participants don't get heavy content at one single time for exam. Okay, so we'll 50% of the content. One exam will be conducted for the first 50% of the curriculum, and second exam will be conducted for the next 50% of the curriculum. So it is not going to be very heavy for the participants. So once, and we'll take the weighted average of both the exam. So once participant clears the exam, it scores more than 70%, we give them the certification of excellence. So certification of participation is allowed for everybody. We'll give for every participant, we'll give the certification of participation certificate. But as far as the excellence is concerned, so that person has to give two exams and score an average of, no, the average has to 70%. So for first exam could be 40%, next exam could be 100%, right? So the average is 70%. So we're going to take the average. Yeah. So recognition is, because we're getting is registered with Government of India in another maybe by 2.5 months or 3 months. We're going to register with Government of India. We're also getting affiliation with ISO, right? So we are also in touch with various universities. So the universities things will take another 6 months to 1 year, but we will upgrade the certificates later on once we get it. But as of now, we are saying that in the next 3 4 months we are going to affiliate the certificate with ISO and like Skill India programs, Grameen programs, MSME certificates. So MSME, so all those things we are going to we are actually in the process of affiliation right now. So from the affiliation point of view, we are going to give good affiliations. From the market point of view, the quality of training and the quality of module is so high that participants who are appearing for job, who are looking for jobs, who are actually who are working in any company, their performance levels are very very high from the content point of view and the performance point of view. From the affiliation point of view, yes, we are in the process, and we're going to take another 3 or 4 months to get the ISO and the Indian government affiliations. So that is on the process right now. We are doing this, we deliver. Yeah, we're delivering this course since last 6 years. We started in 2016, 2016 December. We started this. So and we have delivered these sessions to various corporates. We have delivered these sessions to various universities. We delivered these sessions to various MBA colleges. And our participants are generally from international, from US, Europe, Middle East, Asia Pacific. So from different countries, participants are there. So we are delivering this training program, and we have structured this program based upon the needs of the current market. So we have done various analysis with various companies and various things. So we have structured. It's a very well structured program based upon the experiences which we have from the consulting exercises. So we are not purely a training company. We are a consulting company. So we have provided consulting to almost 100 plus companies till now. So this training program is delivered not from the books. This training program is delivered from our consulting experiences, right? So this is one of the quality thing you'll get from here. So what you learn from here, you can directly implement in any company you're going to join or work. And from the point of interview to the point of delivery, you're going to, you have a full command, because this training program is being delivered or being created based upon the consulting experiences which we had of our almost 22 years. And the and we are being to market into purely into training since last 6 years, 6.5 years. Yeah, there are a lot of people out there who have taken this profile, taken this training, and they have either moved higher into the companies or moved outside their companies with a higher packages, with higher credibilities, right? So if you look at the content, and the content is not being 98% or 99% of the supply chain staff is not using this, not having any knowledge on this. That is the current status of the market. People who are learning, they are the outliers. They are the outliers, and they're doing very well. Recent one experience we had, he was from the person is moved into the senior management level, CXO level. He was into senior management means like senior manager or something. Now he has moved into CXO level because he has handled the projects based upon these skills, and the kind of success he got, he moved into very high level. There are a lot of companies who approach us for the professionals who have got training on this particular domain, right? So we provide, we don't take any money from uh, the the companies for hiring, and we don't take money from our participants also, separate money for this. We People who have passed the exam, we refer those people to the clients who connect with us. Also, we go for consulting programs all over the world. So when we go to consulting programs, so clients ask the because when we deploy the models, we need somebody who can manage them. So clients also ask us the skilled people. So we also refer the skilled people to our clients. These are all the various modes we actually we help participant to get the right profile or right client, or we help the client to get the right participant. And people have learned from us, they sometimes they don't require our help, because they if they have passed the exam, they are skillful, really skillful people. They can independently go into the market, get the jobs, and if they already have a job, they will do extraordinarily good, because that kind of training we provide based on mathematics, based on supply chain, based upon data, based on tools. So this is very high skill, and people get very good. People do very good after learning this. It depends upon yeah, it depends. Sometimes with seven batch, 7 to 7 is sometimes with seven. It is sometimes 7 people per batch, sometimes 10 people per batch, sometimes 4 people per batch, right? So it will not a big batch. It will be almost less than 10. Like there are two ways. Yeah, the same like what we're talking, right? In training session, we will be having interactive sessions. That one thing. Second is that if suppose somebody is doing something on the practice back end at home, so what they can do, they can suppose I'll show you this chat section. There is an option of chat here, right? So like this, the students will come back to us. They will chat. They'll they'll give the screenshot of the pictures. They will share the data, which data they're having a problem. Right. So like this, students will come back to us. So there are a lot of students who come back to us. They write their problems, and we solve the problems over here. So this is how it goes on. So this chat option is there, and second option is we also have WhatsApp groups, right? So we have a WhatsApp group. So in the WhatsApp group also, people can connect to us. So we also interact with people on the WhatsApp. Suppose once a batch is created, we'll create a separate WhatsApp group. People can actually interact with us on the WhatsApp group also. So there are two ways, right? One is the chat option over here. From this, people can connect to us. And the second option is a WhatsApp group. From there also people can connect with us. This will be there for indefinite. The chat option is chat access will be there in indefinite. Yeah, for platform as well as WhatsApp. The only thing we will not give the video recording access after 1 year. The login credential will be there after 1 year. So we'll only remove the access to the video recordings. That's the only limitation. Yeah, 3 years. 3 years. 3 years. Yes, yes. No, from the moment you complete it, suppose you'll give the exam, suppose in the month of November, right? Suppose let's we finish the course by the end of October and you give the exam by the mid of November. So like from it will be calculated from the mid of November. The issue date will be the date when you pass your exam. So I told that there are two exams. So one exam is at the middle of the course, 50% of the course, and the second exam will be the yeah, one paper will be there. Yeah, it will be data exam. It will be completely a data analytics. It's not like a paper exam. You don't have completely a data modeling exam. So we this is a modeling course, data modeling course. So we'll be giving 3 or 4 modeling scenarios, right? So you have to do the modeling. It's not we don't want people to write text or write all those things. We completely a data modeling course, and the exam will be also will be tested on the data modeling skills. There's no multiple choice questions. There is no, you know, what do you say, write a textual answers. It's not completely data analytics, modeling capability, skill. It will be the 3 hours. Yeah, yeah. There are three attempts which you give free. Three attempts for the first exam and three exams for the second exam. After third exam, we charge 2,000 rupees per exam. So three attempts are free for the first exam and three attempts for the second exam. And paper will be different. Every time the paper will be different. So exam, right? We give the modeling exercise. Suppose the person has not has been unfortunately the person has not been able to pass. Will he can actually he can go for the second exam, and the second exam will be different from the first exam. Similarly, third exam will be different from the first two. N- n- Yes, yes, that is general process. So the participant certification is different. Excellence is critical one. People who pass excellence exam, they yeah yeah. Please go ahead. Please go ahead. Please go ahead. Yeah, see, machine learning algorithms, right? So if machine learning, yeah. So this is if somebody learns this program, they are going to feel very comfortable with the AI. So what the machine, if you let me share the course, let me see the model which you're learning in this is like decision trees, uh, right? Support vector machine. These are all the algorithms we are going to learn. Third is our adaptive boosting techniques. There are random forest, right? Fifth is multiple regression. Sixth is your logistic regression. Seventh is your market basket analysis, right? So these are all the algorithms which are machine learning algorithms. If we learn these algorithms, then we can do AI. Without this algorithm, we cannot go into AI. So we are learning this algorithm in the program, like forest analysis. Then we're doing ARIMA, right? Sarima, right? Garch, Arch. The various modules are there. So these all modules, if we learn, then we can think about AI. So these are all machine learning algorithms. So once without learning machine learning, we cannot even think about AI. So that's why this course is one of the best course because nobody provides this machine learning forecasting through machine learning. What we are doing is we're providing machine learning algorithms in the forecasting. These are all the key areas which no one providing. So if we do this machine learning, then we can do AI. So these are all the very cream, very super algorithms, very super machine learning algorithms. If somebody knows, and that too, we'll be doing in some of them we will do in Excel. Okay, all of them we will do in Excel. All of them will be done in advanced Excel, and few of them will do in Python. Only few, not all of them. Few. So, so through this course, a person gets exposure of the Python. Of course, gets the complete understanding about the processes on Excel. So, if somebody is stuck in code, somebody is not good in coding, right? Somebody doesn't want to learn coding, but still wants to be a good force in this field, right? By knowing minimal coding or no coding, then Excel is the route. So person, even if he doesn't know coding, if he's not good in coding, he can take the Excel route and do all this analysis and create performance improvement in the business. This is another advantage in no coding and coding. So coding, we are going for Python. No coding, complete Excel. No coding. See, the only thing, see, the only thing what we require is, we will be providing training step by step, right? We'll be giving the complete visibility of steps of algorithm, the mathematics behind the mathematics which we have, right? To build this, everything is based on mathematics. How to apply this mathematics on Excel, how to apply this mathematics on Python, right? We'll give step by step visibility. The person has to work hard and practice. This is the only thing the person has to do. We have a program, even a layman comes, we'll make them train. Our training structure is derived for a layman, not for an expert. Of course, expert will benefit. The important thing is that the person has to work hard because this is not such an easy subject. This a person needs to work hard. We'll give the total visibility about the algorithms, how that algorithm has been derived, what is the step-by-step process. Everything will give. Person, even layman will understand it. The person should have the curiosity. The person should have the inclination. The person should have the determination to work hard. That's all the thing. Our course is designed for a layman. Our training methodology is defined for a layman. But a person, if he doesn't work hard, then he will struggle because this is, you know, because we are going to bring three aspects over here. The three aspects are, first is supply chain, second is mathematics, and third is tools. The person will learn three things from this training program. And fourth is, of course, decision making. Right? The four things the person will learn from this training program. And everything is delivered step by step. Because we understand this requires a lot of hard work and attentiveness. So we will be giving everything step by step and how to link them. How to link them is our link them to apply on business is our forte. Person will also become the same. We are going to deliver the processes. We'll do everything in a process. How to work on supply chain by using mathematics, what kind of tools we need to use, how can we make decisions. This is a process, complete process is involved. We'll train the person on the process. The person will understand the steps and will train the person on the process. So our methodology is very clear. What we want to deliver is very clear. What we want to generate from the participant is very, very clear. And how this information, how this training, yeah, everywhere, anywhere. There is no such limitation that because we are working on our domain is data, right? Our domain is data. Our domain is not industry. It can be applied anywhere. Our domain is data. So where we have a data, there we can go and work, irrespective of any industry, irrespective of anything. If we have a data, we can work anywhere. We can apply it anywhere. Just we need a data. Right now, we are working on supply chain domain. If it is medicine, if it is hospitality, we can still work on this. Even if it is defense, we can still work on this. Even if it is like pharmaceutical, we can still work on. Even in sports science, even in sports science also we can work. The person should have the rational thinking. That's all. If he has a rational thinking, he can work. He can apply. He can use this in any field. We work in all these fields. The only thing is what we We have a process to approach that, and that we use the rational thinking to get it. But of course, we are going to work on supply chain domain here. But if somebody has a good rational, he can apply in any domain he wants. He can use in any domain. Yeah, this is the certification on demand forecasting. Certification on demand forecasting and inventory analytics. This is a course. For example, this is how it will be. Certificate of Mastery in Demand Forecasting and Inventory. They are awarded prestigious certificate of in mastery in demand forecasting. The recognition signifies a commitment to continuous learning and showcases your proficiency in leveraging analytics to drive innovation and create value across supply chain. So this is how the certificate will be. In Hyderabad, yep. Okay, so let us know if you want to register, and yeah, so we will be helping you from the day one to the day last day end. We'll help you in gaining concepts very well. We have a very structured training process, right? So nothing will be confusing. Everything happens in a very structured way, in a very process way. So nothing is very clumsy because, and so we are also people who are, suppose in 40s or 50s, they can also learn this program. And because our training program is very structured. That's one of the best thing. Okay. So Mr. Rao, any questions from this? Yeah. Thank you, Amit. Thank you very much for your participation today. Look forward for your registration. Yeah. Yeah, Mr. Rao. I think that's okay. Okay, Mr. Amit, then let's connect on WhatsApp, and then we'll see where you go from here. Thank you. Thank you very much.